Dear friends, welcome to the next problem of gears, that is problem number 13. The data of the problem is two 20-degree involutes per gears having a velocity ratio of 1 upon 2.5 mass externally. The module is 4 mm and the addendum is equal to 1.23 module. The pinion rotates at 150 rpm. Find 1. Minimum number of teeth on each wheel to avoid interference, and 2. Number of pairs of teeth in contact. Friends, let us note down the given data. Here the pressure angle is given, phi is equal to 20 degree. Velocity ratio is given 1 upon 2.5. Module is given 4 mm. Addendum is given equal to 1.23 times module. The speed of the pinion is Np is equal to 150 rpm. We have to find out minimum number of teeth on pinion to avoid interference, and same for gear. We have to also calculate the contact ratio. Now we know that the velocity ratio is given Vr is equal to speed of the gear Ng divided by the speed of the pinion Np, and that is given 1 upon 2.5. We also know that the ratio of speeds of gear to pinion is equal to number of teeth of the pinion divided by number of teeth of the gear, and that is nothing but 1 upon gear ratio, and that is given Ng upon Np is equal to 1 upon 25, that is 0.4. Again, here it has been given that addendum is equal to 1.23 times module. So the addendum factor AW is equal to 1.23. Now we know that the minimum number of teeth on gear to avoid interference is given by capital T is equal to this relation. Upon substitution of values of AW and 1 upon G and pressure angle phi, we found the T is equal to, on calculation, is 45. Now it is known to us small t upon capital T is equal to 1 upon 2.5, and substituting the value of capital T, we found small t, that is minimum number of teeth on pinion required is equal to 18. Now the number of teeth pairs in contact is nothing but contact ratio, and the contact ratio is given by arc of contact divided by circular pitch, and we know that the circular pitch is given by pi m. So the contact ratio is equal to arc of contact divided by pi m. Let us say this is relation number 1. And also the arc of contact is equal to path of contact upon cos phi, say relation 2. And the path of contact is given by path of approach plus path of recess. And substituting the known equations for path of approach is this and path of recess is this. So path of contact will be this relation, let us say number 3. Here in this equation, capital R indicates the pitch circle radius of gear given by m into number of teeth of gear by 2. On substitution the values, we found capital R is equal to 90 mm And capital RA is the addendum circle radius of gear, that is pitch circle radius plus addendum. On substitutions of the values, that is 90 plus 1.23 times module, where m is given 4, and so RA is equal to 95 millimeter. And small r is pitch circle radius of pinion given by this relation. So on substitution of the values, we found r is equal to 36 mm, and small ra is nothing but addendum circle radius of pinion, that is pitch circle radius plus addendum. And on substitution of values, we found ra is equal to 41 mm. So substituting these values in relation 3, we found that path of contact is equal to, on calculation, 12.49 plus 10.85 is equal to 23.34 millimeter. So using relation 2, we can calculate arc of contact is equal to path of contact divided by cos phi, and we found it is equal to 24.83 millimeter. Again, using relation number 1, we can calculate contact ratio is equal to arc of contact divided by pi into module. On substituting the values, we found contact ratio is equal to 1.97. So, we can conclude that the minimum number of teeth on the gear to avoid interference is 45. Minimum number of teeth on pinion to avoid interference is 18, and number of pairs of teeth in contact is equal to 1.97. Thank you friends, and you are welcome to raise any query or question. You can write in comment. I will like to answer. Thank you.